Find the values of x and y in the triangle below. Correct your answer to 1 decimal place. This is a right-angled triangle, and we are going to apply the trigonometrical ratios in solving this problem. So to start with, we have to identify the given angle in the problem. So we call it theta, and that's equal to 40 degrees, which represents the given angle. Then we have to identify the hypotenuse, the opposite, and the adjacent. The longest side, which is facing the right angle, is the hypotenuse. So we have our hypotenuse is equal to x. Then we look at the opposite. The side that is opposite to the given angle is called the opposite. So we have it at 7 centimeters. And the third side, of course, is the adjacent. So that will give us the y as the adjacent. Now we go ahead to find the values of x and y. Now to calculate x, we need to combine the x and a given side. So here we have the hypotenuse, and the given side we can combine it with is the opposite. So, and the ratio connecting the opposite and the hypotenuse is sine. So we have it as sine 40 degrees is equal to 7, which is the opposite, over hypotenuse. Sine is opposite over hypotenuse, so the opposite is 7. Hypotenuse is x. We now find the value of sine 40 degrees, and that gives 0.6428 is equal to 7 over x. Then we make x the subject of the formula. Making x the subject of the formula, we have x is equal to 7 over 0.6428. And from our calculator, we have our answer as 10.89 centimeters. And to 1 decimal place, we have the answer as 10.9 centimeters. Now, to calculate y, we are going to connect y and any of the two known sides. So we see combine y and the opposite. Y is the adjacent side, and 7 is the opposite, and the ratio combining the adjacent and the opposite is tangent. So we have tan 40 degrees is equal to opposite 7 over adjacent, 7 over y. So again, we find the value of tan 40 degrees. Tan 40 degrees gives 0.8391. This is equal to 7 over y. Again, we make y the subject of the formula here. If you make y the subject of the formula, you have y is equal to 7 over 0.8391. And from our calculator again, we have y is equal to 8.34 centimeters. And to 1 decimal place, we have it as 8.3 centimeters. By this, we have solved the problem, thereby finding the values of x to be 10.9 centimeters and that of y to be 8.3 centimeters. Problem 2. Find the value of x and of y in the triangle below. Correct your answer to 1 decimal place. So we have the two right-angled triangles here combined to form a quadrilateral. So here, to ease our work, we can label the shape. So I have A here, B, this point C, and D. So from here, we are going to find the value of y first, because we need the value of y to find the value of x, since there is no given side in triangle BCD. So we are only given side x and the angle, so we cannot combine x and any other side. So we need to find the value of y first before we can find the value of x. So to do that, we consider triangle ABD. So we consider the triangle ABD, this triangle here. So considering this, the given angle is 62 degrees and the opposite angle here is 8 centimeter, that is AD. And the side we need to calculate is BD, which is represented by y. So we are now combining the opposite and the adjacent. Combining opposite and adjacent, we have a tan. So we have tan 62 degrees is equal to opposite over adjacent, and our adjacent is y. So finding the value of tan 62 degrees, we have it as 1.8807 is equal to 8 over y. And now make y the subject of the formula in this relation. We have y equal to 8 over 1.8807. From our calculator, we have it as 4.253 centimeters, and to one decimal place I have it as 4.3 centimeters. Then we now go ahead now to find the value of x, having known the value of y. So to do that, we still have this one as the adjacent, and the x is the hypotenuse. So we are combining adjacent and hypotenuse. So combining adjacent and hypotenuse, we shall use the trigonometrical ratio combining cosine, adjacent, and hypotenuse. So we say from triangle BCD, so we have cos 35 degrees is equal to adjacent, and our adjacent is y, and the value of y is 4.253. We shall be using the raw answer, not the approximated answer in subsequent calculation. So we shall use adjacent 4.253 over x, that is over the hypotenuse. So the cosine is adjacent over hypotenuse. The value of cos 35 degrees is 0.8192 is equal to 4.253 over x. We make x again the subject of the relation here. Making x the subject of the relation, we have 4.253 over 0.8192. Again, from my calculator, I have the answer as 5.192. The final answer is 5.2 centimeters to one decimal place. Problem 3. Calculate the triangle below completely. So we have the right angle triangle. To calculate the triangle below completely, we need to calculate the unknown side and the two angles of the triangle. So to calculate the unknown side here, to calculate the triangle completely, we shall calculate the unknown side and the two angles. So we can label them. This is side A. Call this angle here alpha and call this angle beta. We shall start by calculating the angle alpha. To calculate angle alpha, we shall combine the opposite and the adjacent. That's going to give us tan alpha is equal to opposite over adjacent. tangent is the one combining opposite over adjacent, and that will give us 0.8333 to 4 decimal places. So from our calculator or 4-figure tables, we find the tan inverse of 0.8333 to get the value of alpha. So alpha is equal to 39.804 degrees, and that will give us 39.8 degrees to 3 significant figures. Now, to calculate angle beta, what we just need to do is alpha plus beta is equal to 90 degrees. Since this angle is a right angle, so the two other angles are complementary, and complementary angles are angles whose sum gives 90 degrees. So from here, beta will be equal to 90 degrees minus 39.804 degrees. I have told us earlier, you don't use the approximated value in calculation. We use the unapproximated value. So from here we have beta is equal to 50.196, and to 3 significant figures I have 50.2 degrees. To calculate A, we shall use Pythagoras theorem. Using Pythagoras theorem, we have a squared, that is the hypotenuse, is equal to 6 squared plus 5 squared. 6 squared is 36 and 5 squared is 25. So 36 plus 25 gives 61, meaning A squared is 61, and A is square root of 61, which is 7.81 centimeters to 2 decimal places, and finally we have it as 7.8 centimeters to 1 decimal place. Problem 4. Given that 0 degrees less than x less than 90 degrees and sine x is equal to 12 over 13, evaluate cos x plus 1 over tan x minus 1. In this case, we shall represent this information in a right angle triangle. So representing this in a right angle triangle, we need a right angle triangle ABC. So identify any of the angles as x. So we have this as x. The ratio concerning sine is sine theta is opposite over hypotenuse. So from here, our opposite is 12 and our hypotenuse is 13. Call this side B. So this side B needs to be calculated. To calculate this, we shall use Pythagoras theorem. So we have B squared is 13 squared minus 12 squared. So from our calculator, B squared is 25 and B is equal to 5. So we can now go ahead to find cos x and tan x. So to start with, cos x is adjacent over hypotenuse. So our adjacent here is 5. So we have 5 over 13. And tan x is opposite over adjacent, that is 12 over 5. Now we go into the problem. Look at cos x plus 1 first. Finding cos x plus 1, we have 5 over 13 plus 1, and that will give us one whole number, 5 over 13. So we find tan x minus 1, that is 12 over 5 minus 1. 12 over 5 is 2 whole number, 2 over 5, so we can have this as one whole number, 2 over 5. So from here, we bring in the expression to be evaluated. Since cos x plus 1 is one whole number, 5 over 13, We shall change it to improper fraction. 13 times 1 is 13 plus 5 gives 18 over 13. Since this is divided by the denominator, 7 over 5. If this is changed to improper fraction. So from here we have 18 over 13 times 5 over 7, thereby giving us 90 over 91, which gives the solution after evaluating cos x plus 1 all over tan x minus 1. Problem 5. The angle of depression of a point on the horizontal ground from the top of a tree is 58 degrees. If the point is 10 meters away from the bottom of the tree, what is the height of the tree? We need to give a diagrammatical representation of the information in the problem. So here we have to get the horizontal ground, then get the height of the tree, then we said the angle of depression of a point on the horizontal ground from the top of the tree. So get the top of the tree to be T and the bottom to be A, and from the point we call it B on the horizontal ground. So the angle of elevation, let this be normal. If this person is looking normally, this is the line of normal. Then looking down to the horizontal ground, an angle of 58 degrees is made. So here is the angle of depression here. The angle the normal makes with the line of sight. And the line of sight here is this. If the point is 10 meters away from the bottom of the tree, which means AB is 10 meters. So remember, this angle is a right angle. So from here, we are to calculate the height of the tree. Calculating the height of the tree here, we call it x. So from here, we need to calculate one of the angles here. This angle is equal to this angle, alternate angles. So this angle here is alternate to this angle, since AB is parallel to the line of normal. So here we shall combine the opposites and the adjacent. That will be giving us tan 58 degrees, which is equal to opposite. Opposite is x, and our adjacent is 10. We have it over 10. So we find tan 58 degrees. Tan 58 degrees is 1.6003, which is equal to x over 10. Now cross multiplying, we shall have our x equal to 1.6003 times 10 gives 16.003 meters. And to the nearest whole number, we have it as 10 meters. Problem 6. A boy stands 20 meters away from a telecommunication mast. His angle of elevation of the top of the mast is 60 degrees. If his eyes level is 75 centimeters above the ground level, calculate the height of the mast. Leave your answer in short form. Here we have the horizontal ground, the telecommunication mast, the height of the boy, and since the boy is 20 meters away from the mast, this is the line of normal of the boy, and this is the line of sight from the boy to the top of the mast, and the boy is making angle 60 degrees. So from here, the height of the boy is 0.75 meters, is 75 centimeters, converted to meters gives 0.75 meters. So from here, we have this as right angle. Let this point be A, the top of the mast be B, and the position the boy is standing be C, and the height of the boy be CD. Take the height of the boy to be CD. So from here we take the normals of the site on the mast to be E, the point of normal of the site of the boy on the mast to be E. Now from triangle BED, we are going to calculate BE, and we call it X. So we are going to combine the opposite and the adjacent again. Since ED is 20 meters, so we have a trigonometrical ratio which is tan 60 degrees equal to opposite X all over adjacent, that is over 20. So from here, tan 60 degrees in short form is √3 is equal to X over 20. And cross multiplying, we have X equal to 20√3. So from here, the height of the mast is 20√3 plus 0.75. From here, we have to add AE. So adding AE, we have it at 20√3 plus 0.75, all in meters. Problem 7. A ladder 13 meters long leans against a vertical wall. The foot of the ladder is 5 meters away from the bottom of the building. A. How far above the ground is the top of the ladder on the wall? B. Calculate the angle the foot of the ladder makes with the horizontal ground. So we need a sketch of the information and the problem. So we always get our horizontal ground, then the wall of the building, and the ladder leaning against the vertical wall. The ladder is 13 meters, so we have the ladder to be 13 meters. So remember, this is right angle. Name this point A, this one as B, this as C. And again, the foot of the ladder is 5 meters away from the bottom of the building. We have AC to be equal to 5 meters. Problem A, how far above the ground is the top of the ladder on the wall? So we are going to calculate AB, call it X. So from here we shall be using Pythagoras theorem. This is the hypotenuse. So we have x squared is equal to 13 squared minus 5 squared. 13 squared is 169 minus 25, and x squared is 144. X is equal to 12 meters. So we are done with A. We go to B. Calculate the angle the foot of the ladder makes with the horizontal ground. So here we are going to calculate this angle here, call it theta. We shall now combine the opposite and hypotenuse, and the ratio combining opposite and hypotenuse is sine. So we have sine theta is equal to opposite, that's 12 over hypotenuse, and our hypotenuse is 13. So this is 0.9231. Therefore, theta is equal to sine inverse of 0.9231. From our calculator or mathematical tables, we have theta equal to 67.368 degrees, and to 3 significant figures, we have theta to be 67.4 degrees. This brings our trigonometrical lesson to an end. Thank you.